Hello everyone, welcome back to my channel Code with Malika. Today we are going to solve a LEETCODE September challenge problem, that is candy, and it is a hard level problem. So it will comprise of basically two approaches. One will be uh, a brute force approach or a naive approach, you can say, and the second one would involve space optimization. So considering the length of this video, I have divided this into two parts. So the first part, that is a brute force approach, we are going to solve. So let's get started. All right, let me jump onto the question. I think this is about okay. The question is that there are n children standing in a line and each child is assigned a rating value given in the integer array ratings. Okay, so you are giving candies to these children subjected to the following requirements. Each child must have at least one candy, and the child with a higher rating will get more candies than its neighbors. Okay, so we have to return the minimum number of candies we need to distribute. All right. Now, suppose let me take an example. Uh, just a second. Yes. Let me take an example which they have taken in they have given in the question as well. So what they are saying is, let me create an array of ratings. So it will be 1, 2, and 3. Okay, that is 1, 0, 2. So these are the ratings of an array. Now what they are saying is we have to distribute candies. So considering this, what should be the distribution for this? At least we have to allocate we have to allocate minimum one candy to each child. We can assume that the array which we are creating for distribution of candy should be initialized by 1, as every child must have one candy as well. All right, one candy has been allocated to each of the child. Now we'll compare with the neighbors. So suppose we are considering one. Okay, let me change the color. We are considering this. Okay, I think yes, it is a bit. Never mind. So we are considering this, and we are comparing, is 1 greater than 0? Yes, it is. So it should have value greater than the candy present with this rating child. The 0 rating child has the candy 1. So it should have 1 plus 1, that is 2 candy. Okay, it should have 2 candy. Now let us come to 0. 0 is not greater than any either 1 or either 2, so it will remain as it is. Then we'll go on to 2. So 2 will have 2 is greater than 0. So it should have a candy greater than the value present for the 0 rating child. So it should be 2. ओके, सो मैं थोड़ा सा सिंप्लीफाई कर देती हूँ इन केस एनी वन इज़ नॉट गेटिंग व्हाट आई एम सेइंग कि जो हमारा रेटिंग है, दैट इज़ 1, 0 एंड 2 इज़ द रेटिंग. सबको मिनिमम 1 1 कैंडी अलॉट हुई है, एंड फॉर एवरी चाइल्ड रेटिंग वी आर कंपेयरिंग. इन केस द रेटिंग इज ग्रेटर, वी आर एडिंग दैट वैल्यू टू द नेबर्स कैंडी वैल्यू. दैट इज 0 बड़ा है, सॉरी 1 बड़ा है 0 से, and इसका neighbor 0 है. We are not comparing 1 with 2, we are directly comparing it with 0, because 0 is the neighbor of 1. इसके 0 के पास जो allotted value है, that is 1, उससे एक नंबर बड़ा होना चाहिए. So it would be the answer would be 5. Okay, so I think this is what they have given in the test case. But even if we can count upon as a greedy approach, and we are trying to minimize or we are trying to allotting, but it will fail and it won't work. Let me tell you why. Okay, so let me clear this out. Okay, let me take an example. Suppose for the example I can say that it is 1, it is 3, it is 5. Okay, 5, and 5, 5, let it be 5, let it be 2, and let it be 1. Okay. So suppose this is the rating array which we have taken. Now, according to our logic which we have created till now, what should be the said logic? It should be this way. Yes. What should be the logic? That सबको हमने we have assigned one candy to everyone. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Okay. Now we have allotted one candy to everyone. Okay. उससे नीचे तो आप allot कर नहीं सकते हैं. So okay. Now we'll start with 1. Is 1 greater than 3? No. Is 3 greater than 1? Yes, it is greater than 1. So the value should be 2. Okay. Is 5 greater than 3? Yes, 5 is greater than 3. So what should be the value? The value should be 3. Okay. Sorry. The value should be 3. Why 3? 5 3 से greater है और 3 के पास 2 candies हैं and 2 plus 1 must be 3. Okay. Now 5 is not greater than 5 and 5 is not greater than 5. So it will remain as it is. Similarly 5 is not greater than 5 and 5 is greater than 2. Okay. So it will take the more value, that is it will add 1 to the number of candies present with 2, so it should be 2. Okay, now let's come to 2. Is 2 greater than 5? No, 2 is not greater than 5, but 2 is greater than 1. Okay, so now here our problem begins. It should be 2. See what is happening here. This value was depending upon this value. Okay, and we are not backtracking the manipulated value. That is, एक flow ऐसे चला गया, then you are not coming back to check कि कहाँ क्या change हुआ, कहाँ manipulation हुआ. So for this issue, due to this issue, we won't say that backtracking will work. Okay, now what will work, which approach will work, let me tell you. So what we'll do is, let me remove everything. Okay, now we'll create two arrays. Okay, we'll create two arrays. Let it be left array and let it be right array. Okay, now I want to move it a little bit downward. Can I move it? Okay, let me figure it out later on. So I'll start first. Yes. So first we'll start with left operation. So what I want to say is that earlier what we were doing, we were checking here and then we were checking here. So instead of checking both, let us check with the previous one. Okay, see what will we'll create one array, that is, let this array do this operation, and we'll check for left side first, that is 1 will compare to 3 only, 3 will not be compared to 5, 5 will compare to 3, 5 will compare to 5, 5 will compare to 5, 2 will compare to 5 and 1 will compare to 2. Okay, so how this will work? This is our left array. Okay, and for left array, is 3 greater than 1? Yes, so 3 should have a value more than 1, 1's rating. Yes, so it should have 2. All right, is 5 greater than 3? Yes, so what should be the value? The value should be 3. Cool. Value is 3. Okay, now is 5 greater than 5? No, so value is as it is. 5 greater than 5? No, the value is as it is. 2 greater than 5? No, the value is as it is. 1 greater than 2? No, the value remains as it is. Okay, now what we'll do is, this is first traversal which we have done this way. Now what I want to do is, okay, where is an eraser? Okay, now let me remove this. Yes, now what I want to do, now I have traversed this, now I want to check it this way, that what 2 will compare to 1, 2 will compare to 1, 5 will compare to 2, 5 will again compare to 5, 5 will compare to 5, 3 will compare to 5, and 1 will compare to 3. So the results will be stored here. What would be the results? Let me check. 6 and 7. Okay. 2 comparing to 1 is 2 greater than 1. Yes, it is greater than 1. What should be the value? The value should be, okay, okay, initially we have stored 1 here. What should be the value? The value should be 2. Why 2? Because this is 1. Okay. 5 greater than 2? Yes. So it should be 3. Why it is 3? Because 5 is greater than 2 and 2 is having 2 candies. Okay. Is 5 greater than 5? No. 5 greater than 5? No. 3 greater than 5? No. Is 1 greater than 3? No. So it will remain as it is. Now we'll create an answer array. That is the answer array which we'll create here. Yes. What we'll store in the answer array? We'll store the maximum of these. Okay. Okay. So how we are going to store it? Let me bifurcate. 1, 2, 3, 4, 5, 6, and 7. 1, 1, 1. 1, 2, 1, 2. 2 as 2 is maximum. 3, 1, 3. 1, 1, 1. 3, 1, 3. 2, 1, 2. And 1, 1, 1. So what would be the answer? The answer would be the sum of these elements, that is 3, 3, 6, 7, 10, 12, and 13. Okay. So this is what needs to be done. So what we'll do, we'll write the steps here. Okay. So what would be the steps? First we are going to create two arrays, that is left array, and right array. Okay, and initialize both of them to 1. Okay, I think it won't be visible. Yes, initialize both of them to 1. The second step would involve we'll iterate from I is equal to 1 to I is equal to n minus 1 and compare ratings was the array, I guess. Ratings I greater than ratings I minus 1. Okay. Okay. And the third step would be iterate from I is equal to n minus 2 to I is equal to 0 and compare the ratings for I is equal to uh, and I for ratings I guess I plus 1 and I. Okay, we are, because we are checking further rate and ratings I. Okay, and then we'll further what we'll do is take max of the both array elements, print sum. Okay, so this is what we have to do. Now I'll write the code. What's the code? Okay, so let's get started. Okay, I think there was a glitch in between and we can start with the video again. So as I had started coding, so let's get started. First I'll take the size of the array. Yes, now what we are going to do, we are going to create a vector for storing the candy count. Let it be candy count. Okay, and we are going to initialize it with 1. Now our calculation starts. So what we are going to do for I int I is equal to 0, I less than n, I plus plus, and it should not be 0, it has to be 1. Why 1? Because first we are checking for the left element, so 1 will check to 0. So how we are going to compare? If rating of I is greater than rating of I minus 1, then what we'll do, we'll store it in candy count. I is equal to what is equal to maximum of maximum of candy count I, candy count I minus 1 plus 1. Okay, so this is the case when we are checking from left to right, that is one iteration. The second iteration will be for int I is equal to 0, I less than, no, it won't be 0. See, when we are talking about an array, the last element is n minus 1, and we have to just compare it with the previous one. So we'll start with n minus 2, and I has to be greater than equal to 0, I minus minus, and what we are going to do, so if ratings, it has to be s here, why I am using g, yes, ratings of I is greater than ratings of I plus 1, then the candy count I will store maximum of candy count I, candy count I plus 1 plus 1. Okay, so this is the iteration, that is what here we have done. We have done the calculation in one array itself. Now what we are going to do, we are going to return the sum. So this answer has to be returned in the form of integer, so I am using ans for int I is equal to 0, I less than n, I plus plus, and I am going to initialize this as 0, and how ans plus is equal to candy count I. Okay, uh, I think this should work, so we'll return answer. Okay, I think this should work. It did work. Okay, okay, great. Let's submit. So thank you. See, the runtime here is 14 ms, and the memory it is taking is quite low, quite high, and the efficiency is quite low. So I'll create another video for the same, because it will exceed the time and we'll lose interest simultaneously. There is another way in which space optimization can be taken into consideration. So thank you for watching my video. If this was helpful in any way, please do support me, like, share and subscribe. This gives me motivation. So thank you so much, and I'll see you in the next video. Bye bye.